Good morning, everyone. Today is Wednesday, January 11th. Is it 11th? Really? 111? 11123. Wow, that's interesting. We have four questions for a warm up, all having to do with section 7.2 on multiplying monomials by polynomials. All of the polynomials we've used so far have been binomials, so technically it's not really that, it's just really monomials, but binomials, but polynomials work. So if you want to try these, you're practicing, press pause, try these out, see how you do, and then listen to the answers. Our first question gives us a very simple grade 5 question that says 2 multiplied by the sum of 3 and 4, right? And then it asks us to solve it two ways. The first way is with BEDMAS. So if we were to take this question and to solve this with BEDMAS, we would say, okay, I'm going to add first, because I'm going to do my brackets. I'm going to get 2 times 7. And once I get 2 times 7, the solution for that will be 14. However, if we're going to solve it with distributive property, and I think with our example yesterday or in the last video, I said if I have 3 lemons and if I have 4 limes, and I wanted you to triple that, double that, I could take all of my fruit and clone them, and I would have doubled it. So I would have taken 3 lemons and 4 limes and doubled it. I would have ended up with how many total fruit? I would have ended up with 14 fruit. But really what I'm doing here is I'm asking myself, if I double the lemons and I double the limes, what does that look like mathematically? Well, what I want to write for my work, and most of you didn't do this, I want you to write this step. I'm going to double my 3 and I'm going to double my 4. And that's the work you need to show for how distributive property works. You're really doubling your 3 and you're doubling the 4, giving you 6 lemons and 8 limes, but you still get the 14 total fruit. Okay, and that's what distributive property says. It says when you have a polynomial, in this case a binomial of 3 plus 4, each part of that binomial, each term, I shouldn't say the word part, I should say term, each term in the polynomial must be multiplied by the monomial outside the brackets. Okay, so with a very simple non-algebraic example, that's what the solution is. When we take that idea and then apply it to algebra or algebraic expressions or algebraic monomials and polynomials, the difference with this is I can't solve x minus 3 with BEDMAS because I do not know what number x is. It's an algebraic expression. If I knew what x was, if I said x is 5, then I know that that bracket's going to simplify to be 2. If I said x is 10, I know that x minus 3 is 7 and yada yada. But I don't know because it's been given a variable, so we can't simplify it using BEDMAS. But what we can do is we can simplify it using distributive property. So again, same process with the lemons and limes. I'm going to, in this case, not double. I'm going to multiply each term in the polynomial by 2x. So what my work looks like is multiplying 2x by x, and I'm multiplying 2x by, notice how I'm saying negative 3, because that minus 3 is going to be considered to be a negative 3. When I simplify that, I have a monomial times a monomial, which is going to be 2 times x, which is 2x squared. 2 times negative 3 is negative 6x. And that negative sign actually becomes my subtraction sign that binds the two terms together. 2x squared and 6x are bound by that negative. So it's actually 2x squared minus 6x is your solution. We good on that? Does that make sense? Okay. When we get into our next one, we're taking that same question, and because I gave you this little template here, what you're asked to do is solve with algebra tiles. Algebra tiles. So just like if I gave you in the last one 2 times 7, we can think of that as being the area of a rectangle because we have two sides, 2 and 7, and the area is 14, right, when we think about that. When we then take that idea of area and apply it to this one, we can then say, well, if the width is 2x this time, so I'm going to shade these in as x tiles, right? Our x tile is actually a width of x and our width of 1 and x times 1. The area of that tile is actually a full x. And I take my width and I go x minus 3. There's an x. I'll shade that in. And a minus 3 is minus 1, minus 2, minus 3. So what this now says is it has a length of x minus 3, it has a width of 2x, and the area inside here will represent the product, or the multiplication of 2x and x minus 3. So what you do is you just box it up like this and then connect over all of your parts. Once you have the area drawn in, you have to determine whether or not they're positive or negative. Since this is a positive x times a positive x, it's going to be a positive x squared. So will this. But because this is a negative 1 times a positive x, these are all negative x's in here. So I'm not going to shade them in. I'm going to keep them like that. And actually, if I was shading them in, I'd probably want to shade those ones in solid because they were actually positives. And when I interpret the area, I now have 2 x squareds, and I have 6 negative x squareds, or negative 6. Sorry, not x squareds, x's. Negative 6 x's. And that's the exact same answer we got solving it with distributive property, but I modeled it using algebra tiles. And our last example is the exact same thing, except instead of saying, if I had that last question, the first example, 2 multiplied by, I think I gave 5 and 2 maybe, or maybe it was 4 and 3, I can't remember. In this particular rectangle, I still really have a length of 2, or a width of 2, and a length of 7, but here I could see that this part would be an area of 10, and this part would be 4, which is going to be the same sum as 14 when I look at it from an area model. When I apply that idea to my picture, my width is 2x. The distance from here to here will be the x, and the distance from here to here will be the negative 3. So therefore, the whole distance here is still going to be x minus 3 in terms of its length. So the area inside there will be the product of 2x and minus 3. This one will be 2x minus x, or multiplied by x, which is 2x squared. This one will be 2x for the length and a negative 3 for the width, which will be negative 6. Therefore, just like the other ones, my solution will be 2x squared minus 6.